Okay, so next we're going to take a look at an ellipse. So if you look at this chart here, so rectangular form, remember we have an ellipse here. Remember that A was always the biggest number for an ellipse. So depending on where A was located, so if A is the bigger number under the X, so it's going to be a horizontal ellipse. And then if A was the bigger number under Y, it was going to be a vertical ellipse. So keep that in mind. We'll be graphing some of these so you can remember that. But I want you to take a look at the parametric equations. So these look very, very similar to the circles, okay? But the main difference here is going to be in front of your cosine and sine, they should have different numbers. So remember, for an ellipse, they have different numbers. So that's where you're going to be able to tell this is an ellipse and not a circle, is in front of the cosine and sine. For an ellipse, though, we are going to be using the same Pythagorean identity that we use for circles. So cosine squared t plus sine squared t equals 1. We will be using that just like we did for circles whenever we change from parametric to rectangular or the opposite. So looking at our first problem here, we have x plus 1 squared over 9 plus y minus 3 squared over 25, and that's equal to 1. Okay, so first off, we know this is an ellipse because it's addition, so it can't be hyperbola, and then because these have different numbers on the bottom, that's why it's not a circle. Okay, so this is going to be an ellipse. Couple things, if you remember from an ellipse, we have a center of ellipse, we have our major axis, we have our minor axis, we have our vertices, we also talked about the foci. So we're not going to cover all that stuff today, but just kind of remind yourself those are the vocabulary words that we have. So right now, I just want to change this into parametric form. So because this is an ellipse, we're going to be using the cosine squared t plus sine squared t equals 1. I'm going to write it directly underneath so I can compare. Things to look out for, the x's do have to go with cosine and y has to go with sine, okay? So make sure you set it up that way. So if you take a look here, it was already equal to 1, so you didn't have to do that step where you divided like we did on circles. And something just to save you a little bit of time, you can see these are both squared. They're always both going to be squared. So if you want to go ahead and take the square root of this step, you can. So if I take the square root of cosine squared, that would just be cosine t equals. If I take the square root of x plus 1 squared, that'll be x plus 1. And if I take the square root of 9, that'll be 3. Now I will go back in and talk later. This could technically be a positive 3 or a negative 3, but for right now I'm just going to use the positive. So the goal to get parametric is to solve this for x, so I'm going to cross multiply. And then to get x by itself, I want to move over the negative 1 and I'm going to put it in front. So we get x equals negative 1 plus 3 cosine t. So that's the x part of our parameter. So then if I take a look at the y and the sine, so once again, these will both always be squared. So I'm going to go ahead and take the square root. Square root of the sine squared will just be sine t. Square root of y minus 3 squared will be y minus 3. Square root of 25 is 5. This could technically be a positive or this could be a negative. If I cross multiply, right there, and then I'm going to get y by itself, so I'm going to add it over 3 and put the 3 in front. So 3 plus 5 sine t is equal to y for my parametric equation. So a couple things I want to look at here. For your, they should have cosine and sine for your parametric. It has a 3 here and it has a 5 here. So that tells you that those are different numbers. And because those are different numbers, that is going to be an ellipse and not a circle. Also, these are your numbers for your A and for your B. So guys, your A has to be the bigger number. So your A has to be the 5 here. And your B has to be the 3 here. So because that A was with the sine, that should tell you that this has a vertical major axis. So our ellipse, if we were to graph it, would be elongated vertically. And if you go back and look at the original problem, y squared over 25, 25 was the bigger number, so your A had to come from here, and because it was with the y, that's why it was vertical. So there's one thing. Also, for your center of your ellipse, just like a circle, x has -1 here, so the x-coordinate is -1, and 3 here. So if we wanted to go back and check, it's x plus 1, so that's -1, y minus 3, so that gives you +3. So you can get some of this stuff from the parametric equation without actually having to have the rectangular equations if you had to graph it. Okay? So for our next one, they're going to give us the parametric, and we are going to change it to rectangular, and then we're going to graph it. So they give us x is 2 plus 4 cosine t. And once again, guys, t can be a theta, it can be another variable, it really doesn't matter. Y is -3 plus 2 sine t. Okay, so I want to talk about a few things here. It has cosine and sine, so it has to either be a circle or it has to be an ellipse. Because we have differing numbers here, 4 and 2, it has to be an ellipse. Okay. Now, we know that for an ellipse, we have an A value and we have a B value. A has to be bigger, so the A would have to be 4 here, and the B would have to be 2. Because your A is with the cosine here, that means that this is going to be a horizontal ellipse, so it would be more in this direction here. Okay. Other things we can tell is we can tell what our center of our ellipse is going to be. So the x is 2, and our y is -3. So we will check this stuff whenever we get it in rectangular form and make sure we get the same thing. Okay, so we are going to be using cosine squared plus sine squared equals 1. Before we can use this trigonometry, Pythagorean identity, we need to solve for cosine and solve for sine. So if I take the top one, if I want to solve for cosine, I'm going to subtract 2 first, and then I'm going to divide by that 4. Okay, so if I go ahead and plug this into my equation here, this is cosine squared, so I need to square each part. So it's going to be x minus 2 squared over 4 squared, which is 16, plus in the middle. Then I'm going to solve my other equation for it, sine. So I'm going to add over my 3. I'm going to divide by 2. So sine t is y plus 3 over 2. This is squared here, so I need to square both parts of this. So it's going to be y plus 3 squared over 2 squared, which is 4. And then it has to be equal to 1. So this is my rectangular form of my ellipse. Okay. So let's just check the information that we have, and then we will graph it. So the center we said was +2, -3, which makes sense with what we have here. 16 is my bigger number, so that means my A is the square root of 16, which is 4. B is the square root of 4, which is 2. Because the 16 is underneath the x, this is going to be a horizontal ellipse. So if I want to draw a graph here, okay, I'm going to draw my center first. So my center we said was +2, -3. Okay, so remember graphing an ellipse, your major axis comes from your A. So I'm going to go to the right and left 4 spaces because it was horizontal. So 2. It's hard to see on your own graph. Okay, so that right there is my major axis. My minor axis comes from your B. So I'm going to go up 2 spaces, and I'm going to go down 2 spaces. And then you're going to draw in your ellipse shape. So that's all you really need for the graph. We don't really have to do the focus and stuff. Remember, we could get that from a C value using our A squared equals B squared plus C squared. So just to look back at the chart for an ellipse. So an ellipse is going to have the cosine and sine in the parametric, but the two numbers in front are going to be different. Whereas for a circle, they would have been the same.